Hello everyone, my name is Neil and welcome to Scientifically Speaking, a show where a variety of science topics will be discussed. You can find topics ranging from biology to psychology and even more. All that I ask for you to do is to come into the episodes with an open mind. With all that being said, let's get right into it. American author David Barry once said, "There's nothing wrong with enjoying looking at the surface of the ocean itself, except that when you finally see what's going on underwater, you realize that you've been missing the whole point of the ocean. Staying on the surface all the time is like going to the circus and staring at the outside of the tent." He is right. The ocean is beautiful, but many people don't realize what is underneath it, that whole thing. It has many wonders and curiosities. One of these curiosities are so small, but in big numbers, they can pack a big punch. These little guys I'm talking about are called dinoflagellates, also known as the terrible flagellates when translated from Greek. 90% of dinoflagellates are marine plankton, also known as algae. There are also many freshwater species, some of which have been found growing in the snow. Incredible. They may be photosynthetic or non-photosynthetic. About half the species fall into each category. These cool little critters take up residence within other organisms as symbiotic partners. They may be found in many marine invertebrates, including sponges, coral, jellyfish, and even more. In each case, the host organism is able to swallow the dinoflagellate and incorporate it into its own tissues without even harming it. The dinoflagellate then divides repeatedly to increase its numbers and begins to manufacture carbohydrates, which are provided to the host. The degree of interdependence varies greatly. For instance, the sea anemone, which can survive quite well without its symbionts, while certain corals absolutely have to rely exclusively on the food from their symbionts and build reefs much, much faster, exponentially, with the dinoflagellates present in their tissues. The dinoflagellates are sometimes called phyrophyta, meaning fire plants. This is because some species are capable of bioluminescence, in which chemicals made by the organism produce light in a chemical reaction, which is what we will be getting into. The most dramatic effect of the dinoflagellates on their environment occurs in coastal waters during the warmer seasons. At this time, an upwelling occurs in the ocean, bathing the surface plankton in nutrients from the bottom of the ocean. The surplus of nutrients triggers a bloom of photosynthetic dinoflagellates, whose population density may jump to more than 20 million per liter across some coasts. This high density may color the water golden or red. This is where the name red tide comes from. In some species of dinoflagellates, these blooms are associated with the production of neurotoxins, which are poisons which injure the nerves of marine life that feed on dinoflagellates. The result may be massive losses of fish and shellfish life, as well as other forms of marine life. If animals containing these toxins are eaten by humans, the results may be illness or even death. The most common dinoflagellate toxin is cytoxin, a neurotoxin 100 times more potent than the drug cocaine. It has been found in North American shellfish from Alaska to Mexico, from Newfoundland to Florida. Red tides where cytoxin is mostly produced on the west coast and the east coast of North America. This neurotoxin causes progressive supranuclear palsy, also known as PSP, a brain disorder that affects movement, control of walking and balance, speech, swallowing, vision, mood, behavior, and thinking. The disease results from brain damage to nerve cells inside, of course, the brain. But not all algal blooms are harmful. Most blooms, in fact, are beneficial because the tiny plants are food for animals in the ocean. In fact, they are the major source of energy that fuels the ocean's food web. Scientists at the National Ocean Service have been monitoring and studying this phenomenon for a number of years to determine how to detect and forecast the location of the blooms. The goal is to give communities advance warnings so they can adequately plan for and deal with the adverse environmental and health effects associated with these red tide events. Thank you all so much for watching this episode. My name is Neil, and I'll see you in the next one.